Welcome back. What I want to do right now is talk about something called a PEP, which is a Python Enhancement Proposal, also known under their acronym as PEPs. And if you scroll down to the bottom of this page, you can see I'm actually on python.org dev PEPs. And you can see these different PEPs that we have. There's PEP 1 all the way down to PEP 609 on this particular page. Okay, and there's other informational PEPs as well. So there are a large variety of different PEPs. But the one that we're interested right now is actually this PEP 8. Okay, and this is the style guide for Python code. And what this does is if you get a chance, you can read through all of this stuff, but it talks about things like indentation, tabs or spaces, minimum line length, basically the formatting of all the code that you want to do in Python. And if you scroll down, you can actually read through all this documentation. It's really a good idea to get to know this a little bit. Let's go back into Visual Studio. And just so you're clear, we're going to be using the PEP 8 as our formatting standard throughout this. And let's say, suppose I wanted to do A equals, now let's do that a little more ugly. A equals 10. Okay, this is actually not a very good looking format. Okay, it's just not something that I like to personally look at and read. I like to use more real estate on my screen. I like to make sure that everything is nice and clean and very user friendly, very easy to read. And that's one of the strengths about Python, is that it's very, very close to human written language. Okay, so even from a writing point of view, seeing something like this is not going to be very nice if you were looking at this, for example, in an algebra book. Okay, it's just not very good formatting. I'm going to put this back to its original state to make it a little bit more ugly. What I want to be able to do to make this auto generate or happen automatically in terms of formatting is I want to go up to View, Command Palette, and I'm going to type in this format document. And down on the bottom right hand side of the screen, you're going to see Formatter Auto PEP 8 is not installed. Install with a question mark. And my answer is going to be yes. Great. That's done the installation. So next, what we want to do is test it out. And I want to go to the View Command Palette, and I'm going to click on this Format Document. And you can see here that it actually spaced out that line number 1 code. And then, this makes it much more automatically presentable for me to read. And I'm going to go ahead and hit Control S. Let's try another couple of examples. So I'm going to say B equals 20. And how about this? I underscore love Python equals, let's say 100. This is a ridiculous example, of course. Okay, so you can see that this formatting is absolutely terrible. But if I go back up to View, Command Palette, and then I do Format Document, you can see that it actually went ahead and automatically formatted everything in a much cleaner, nicer to look, or nicer to read view. I'm going to save the changes, Control S, and what I'm going to do is find a way, because I do find that doing View Command Palette each time or Control Shift P is a little bit of a pain in the butt. So there's another way of doing this so that it automatically does it for me. So in order to fix this and do it automatically, what I'm going to do is I'm going to go to File, all the way down here to Preferences, and then up to Settings. Here in the search box, do Format on Save. And it brings you to this box here. So your editor, Format on Save. What I'm going to do is I'm going to go ahead and check that. Okay. And now I'm going to go back to my app, and I'm going to change all of the formatting to this, make it look really ugly. Okay, really close. And you notice that I haven't saved it yet, but if I hit the Control S now, it automatically reformatted everything when I saved the file. So I think that's a really neat feature. So when it actually comes to running the code, there's a couple of ways we can do this, and I showed you before. You can go up to your to the new terminal, and you can type in Python, and then just app.py, and it'll do its thing. You notice here that nothing output to the screen, and that's because I didn't put a print statement in there. But let's suppose I chose, let's say print, and I want to just print out the value of A. Okay, and I can type that. Now I'm going to go ahead and save that. Okay, and now I'm going to hit the up arrow and do Python again. And you can see now down at the bottom that it actually printed off the value of 10 to my terminal. But let's say now I want to print off all the different values. On my IDE right now, I have this thing that says run Python file in terminal. I can go ahead and hit that play button, and you can see a couple of things that just happened. One, it printed out this one here, the original, which is line 4, and then it printed out the values of line 5. But notice here I've got a PowerShell, and the PowerShell is the first one that actually ran the code the first time I ran it with just the value of 10. And then the second one here, Python. Okay, so what happens if I run this again in a PowerShell or in a Python file in terminal? So basically it's going to stick to that one each time I subsequently do this. But let's say I want to do print, I just want to print out B. Okay, and I'm going to go ahead and save that, and I do that again. And you can see now that it's sticking to this Python file that it's doing this in. Okay, so I've got all three of those, which is lines 4, 5, and 6. Okay, so really if you want to run your code in a hurry, that's probably a better option. If you want to do it with a command line, that's one thing you can do right there, is just type it in this way. And don't forget, if you're a Mac user, this is going to be Python 3. But since I'm on Windows, this is all I need. I want to take a minute and talk about what really Python breaks down to. And it breaks down to two different things: your language and an implementation. And really, what is the language? It's just a bunch of rules and grammatical syntax and stuff like that. And an implementation is the program that follows these rules. And so there's a relationship between the two different things, the language and the implementation. Earlier, when we downloaded Python, which was the very first step that we did in the last video, what we ended up actually doing was downloading something called CPython. And this was the implementation. This is what allows us to actually execute the Python code. Now, there are other different implementations out there. So for example, Python is implemented on top of the programming language Java. Okay, and there's IronPython, which is written on the programming language C#. And so as you can tell, this one is written on top of the programming language C. And sometimes you'll hear software developers say, they'll use a phrase under the hood, which means that what you see is Python, but under the hood running your engine is actually C in our particular case. But what is really interesting about the other ones is that the actual original implementation, the default implementation, is CPython. And there is a direct relationship between Python, IronPython, and other versions like PyPy. Okay, so there's sort of a multi-layer relationship between these different implementations. And so why do I really care about this right now? And it's really just a case of variety. Okay, so we have different operating systems. So we've got a Windows operating system, we've got a Mac operating system. Okay, we have different browsers. We've got Google, we've got Firefox, we've got different browsers. And then we have different programming languages. So CPython is just another foundational implementation, but there are other things like Jython that go on top of it. And really, it's just about having different variety. So suppose now you do have some actual code that you want to write. And the way that's actually done is you've got, let's say, for example, the programming language C. Okay, and that looks more like a text-based editor, similar to what we've been doing so far. But this has to go somewhere, and this has to be processed. Okay, and out the other side, the result of this is that we convert everything into something called machine code, which is ones and zeros, otherwise known as on or off or true and false. So I want you to think about this as a bank of light bulbs, 0 being off and 1 being on. Okay, so you've got a whole bunch of light switches in a row, and in this particular case, you would see off, on, off, on, off. That is what the top row of this would be. But in order to do this, we need something to convert the C text-based language into this machine code, and that is what the compiler is meant to do. That's the thing in the middle. So when we compile code, this is what's happening. But this does actually cause a little bit of a challenge for us, because just like with, our machine code, what happens when we have a different microprocessor? So for example, if I've got an iMac, that is going to take a certain type of machine code versus a Windows machine. So they're not going to be compatible machine code, and that can be a little bit of a challenge for us. So we need to overcome that. To address this challenge, Python sort of took the idea from Java. And if you know anything about Java, you'll understand maybe the concept of Java virtual machines. But if not, that's okay, because what we can see is that Python actually took a very similar approach. So they write the code in Python, and then it goes through a process inside of CPython. And then from there, it goes to this thing called Python bytecode. And it introduces another layer of complexity into this. But here's the really magic part. This Python virtual machine is now what gives the ability of Python to be platform or processor independent. Okay, and then from here, this is where we finally get to our machine code that doesn't matter if it's a Mac or a Windows machine, that it can all be used. Okay, so that's really the workaround to dealing with these different processors in terms of how to use or implement Python code. So because they've used this model that was based off of Python, if, for example, you have some legacy code in a project you're working on and you're working in Java, instead of using, say, CPython, you would use Jython, which would be a much more appropriate thing if you're working in the Java environment and you want to implement some of that old legacy Java code into your application. Okay, so this is where the flexibility comes in. So you're either using CPython or even Jython if it's a Java-related project. What I'd like to do now is end this video, because this really did talk about a lot of background issues. We've done some extension work, and we really messed with some formatting. What I really want to do next is get into starting to talk about variables. So that is a very important subject. It's the core foundational stuff that we need to talk about in Python or any other programming language. So I'm going to go ahead and stop this video, and I'll see you in the next video to talk about variables.